Okay, here we go. I am back. Solving quadratic equations part 2. So we're going to continue with the square root property. So factoring is one way to solve quadratic equations, but we can only solve quadratic equations by factoring if the quadratic equation is factorable. If it's not factorable, then we can use what we call the square root property. Oh, if I can spell correctly. I was close. QR, close. So the square root property says if something squared equals a number, so we're going to have our x's in here somewhere, that's always going to be a constant over on the right side, then what's being squared either equals the number or the square root of the number. So let's do another example. Let's suppose we had solve x minus 3 squared equals 25. All right, so now you could take the chance by multiplying and distributing here, x minus 3 times x minus 3, subtracting 25 and setting it equal to 0 and trying factoring, but you may do all that work and find that this is not factorable. So my suggestion is anytime you see a quadratic equation set up this way, something squared equals a number, now we can subtract it and set it equal to 0 and put it into standard form, or we can go right with this really super cool property, the square root property. It says if something squared equals a number, then the square root property tells me right away that what's being squared, so in this case it's x minus 3 is what's being squared, is equal to the square root of this number, or x minus 3 is the opposite of the square root of the number. And then we just turn this into two little simpler equations to solve, keeping in mind everything we learned back in chapter 7. So I always work on the positive radical first. So x minus 3 square root of 25 is a nice number, is just 5. Add 3 to both sides, and we get simply x is equal to 8. We can go back and substitute that in and see 8 minus 3 is 5, 5 squared is 25, so that definitely works. Now there's no extraneous solutions when you solve quadratic equations. If you get an answer, it's a solution, assuming you did the math correctly. All right, now over on this side, we get x minus 3 equals the opposite of the square root of 25, so it's going to be negative 5. We add 3, and we get x equals negative 2. We go plug it in up here. Negative 2 minus 3 is negative 5. That's the other square root of 25. We square it, we get 25. So therefore, my solutions are x equals 8 and negative 2. So when Alex asks you to separate your answers with commas, this is what they're talking about. Now, in fact, this problem you could have distributed and done x minus 3 times x minus 3, subtracted the 25, set it equal to 0, and this one would, in fact, factor and give you the same answers. But again, if it's set up this way, it's screaming for you to use the square root property. So that's what I would suggest, because it doesn't always work out nicely. So let's try another example. Let's do solve. Let's do x minus 4 squared equals negative 9. All right, so if you notice, this is of the form something squared equals a number. So you could take that chance, distribute, add 9 to both sides, and try factoring, but I'm going to save you the work and tell you right now this is going to create a quadratic equation that is not factorable, so you would have wasted your time. But if we have something of the form something squared equals a number, this is screaming to use the square root property. So what's being squared is x minus 4. So if something squared equals a number, then that something either equals the square root of the number or it equals the opposite of the square root of the number. So let's work on the positive side. X minus 4 equals, well, now we have to revisit 7.6. 7.6 works with our imaginary numbers. A negative under the radical is equivalent to I outside the radical. So I squared of 9, we know the square root of 9 is 3. X minus 4 equals I times 3. We're going to make it more visually pleasing, change it to 3i. Now we solve for x. So just like radicals, when we have a radical that we could not simplify, here we have an I remaining in our solution. So the suggestion is to, when we add 4, put the real part of the number first and the imaginary part second. And again, there's a reason for this. When we go over and work on this side, we're going to get x minus 4 equals the opposite. Well, we know the square root of negative 9 is 3i. So negative 3i. We add 4 to both sides. We get x is equal to 4 minus 3i. So notice the relationship between these two numbers. The real part is exactly the same. It has the same sign, but the imaginary part changes sign. These are conjugates. And again, not a coincidence. When a quadratic equation has an answer that involves either a radical that cannot be simplified or an imaginary number, they always come in conjugate pairs. So therefore, my solutions, x is equal to 4 plus 3i, and its conjugate buddy, 4 minus 3i. So I challenge you to go plug that back in, do the work, and show that, in fact, that is an answer to this. All right, so let's do one more equation before we take it up a notch. Solve 2x minus 1 squared minus 20 equals 0. So I don't suggest distributing and trying to factor. It's not going to work. We have something here almost of this form. Something squared equals a number. We have something squared minus a number equals 0. So let's get it into this form by adding the 20 to both sides. Then we can just apply the square root property. So this is equivalent to saying something squared, what my something is 2x minus 1 equals the number 20. So now we can apply the square root property. What's being squared is 2x minus 1. So 2x minus 1 is either equal to the square root of 20, or what's being squared is equal to the opposite of the square root of 20. I always work with the positive radical. So 2x minus 1 is equal to, this is 4 times 5. Good review of chapter 7, 2 square root of 5. I'm going to add the 1 to both sides. We get 2x is equal to 1 plus 2 square root of 5. Do not combine those. They're not like terms. It's just 1 plus 2 times the square root of 5, so make sure you keep those separate. And now I'm going to divide out the 2. And I prefer to write it this way. 1/2 plus 2 square root of 5 over 2. Simplify. 1/2 plus the square root of 5. So here we have a solution that involves a radical that I can't simplify. So without going through all the algebra again, I know if I have an answer that involves either an I or a radical that you cannot simplify, its conjugate buddy is always, always the other solution. So the nice part of the number has the same sign. What changes is the sign in front of either the I or the radical. So therefore, my solutions are x is equal to 1/2 plus the square root of 5 and 1/2 minus the square root of 5. There we go. So what we did up here is we took what was being squared and we isolated it by adding the 20 to both sides and got it into the form something squared equals a number. And then we use the square root property. Ready. Let's try this one, another one. If you think you got it, you're welcome to fast forward or move on to the next section. Solve. Let's do 3 times x minus 2 squared equals, let's do -6. Nah, that's not the example I wanted to do. Sorry. Let's try that again. Let's do solve 3 times x minus 2 squared minus 4 equals -10. There we go. I like that better. A little bit more work. All right, so we want to get it into the form something squared equals a number. So we got to get rid of this guy, we got to get rid of this guy and isolate what's being squared. So we do that by using our algebra skills, our basic algebra skills. I'm going to add 4 to both sides. 3 times x minus 2 squared equals negative 6. Divide out the 3. We get x minus 2 squared equals negative 2. Now we have it into this form, something squared equals a number. What's being squared is x minus 2. So now we can apply the square root property. X minus 2 equals the square root of negative 2, or x minus 2 equals the opposite of the square root of negative 2. I always work with the positive one. Don't leave negatives under radicals, and we do not use the answer, no real answer anymore. We now incorporate the i's. So x minus 2, remember, a negative under a radical corresponds to I out front. I square root of 2. So now here's an answer. We cannot simplify the square root of 2 further. We have an answer that involves both I and a radical. We solve for x by adding 2. And always put this number that we're adding or subtracting first. So it's positive 2 plus I square root of 2. And because this involves either an I or a radical, in this case both an I and a radical, we know its conjugate buddy is going to automatically be the other solution. So without any further ado or any other work, I can always write its conjugate buddy. So therefore my solutions are 2 plus I square root of 2, 2 minus I square root of 2. Here we go. Upcoming. Solve x squared minus 6x plus 4 equals 0. Not factorable. You can try, but it is not factorable. It's also not in something squared equals a number form. What to do? See 8.1 part 3.